Hello class, welcome to Algebra Concepts Lesson 8.5, which is all about simplifying radical expressions. By the end of this lesson, you should be able to simplify radical expressions. So let's quickly review what a radical expression is. Radical is another name for the square root symbol. We're only going to deal with square roots. We're not going to deal with cube roots or anything higher this section, or actually this course, okay? We're just going to focus on square roots. So something to remember is that a square root is the opposite of something squared. Okay, so if I had x squared, the opposite thing I could do to get rid of that squared would be take the square root, and then I'd just be left with x. The 2 and the square root symbol cancel each other. Okay, so we're going to practice simplifying things so that way we don't have any decimals, okay? So something that's really helpful to have is just a list of all of the perfect squares. I mean, not all of them, but the first, usually I tell students if they can remember at least the first 12, that's really helpful. If you can do the first 15, that's fantastic. Otherwise, I'm not concerned about you having all of these memorized. It just makes your life a little easier. So I recommend having these numbers readily available to you as we continue on. Okay, so just to have it readily available, I'm going to start with writing those just along the top. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, 64, 81, 100, 121, and 144. Those are things I like to write along the top of my page. Looking at these 3 numbers, I see that I actually wouldn't need to include any of these numbers because they're all bigger than what's in the square root. So basically what you're going to try to do is you're going to try to see what is the biggest number that can multiply into one of these numbers. So here I have the square root of 16, and the square root of 16 works out perfectly because the square root of 16 is just 4. So that one's a nice, easy number to work with. And then we have the square root of 20. So what's the biggest of these numbers that multiply into 20? So 1 goes in there but doesn't really change anything. 4 goes in there 5 times. 9 doesn't, 16 doesn't. So that means I'm going to split this up. I'm going to say the square root of 4 times the square root of 5. And if I think about that, the square root of 4 is 2. So I would write 2. And then the square root of 5 doesn't break up any further. So this would be how I would write my answer. The square root of 20 as an exact answer is 2 square root of 5. Now, if I look at this next one, I have the square root of 30. So looking at the square root of 30, I check my numbers. Does 4 multiply into there? No. 9 doesn't multiply into there. 16 doesn't multiply into there. 25 doesn't multiply into there. And then these numbers are bigger than 30. So I know that this is actually as simplified as it can be. Okay, so that'll happen sometimes where you're given a square root that's already simplified. So now what I want you to do is I want you to take the square root of 72, and I want you to see, looking at those numbers, what is the biggest number that can multiply into 72 so you can simplify that square root. Good luck. Hopefully you said 36 was the biggest square root, so you said square root of 36 times the square root of 2, and the square root of 36 is just 6, so 6 square root of 2 would be your final answer. Now let's practice simplifying square roots that have variables. So the same idea applies where a square root like this and a square cancel each other. So those would both go away and you would just be left with x. So anytime you're trying to simplify a square root with some variables in it, what you're going to do is you're going to check the power of the variable and see how many groups of 2 are there. So if I look at this, I have the square root of x cubed. I have 1 group of 2, and then I just have 1. So if I check this out, these would cancel. I would just have an x, and then I have a square root of x. So that would be my final answer. Let's try again. If I have x to the 9th, I have 2, 4, 6, 8, and 9. So then what I'm going to do is I am going to cross off any of them that can cancel each other. So here we go. I can cancel 4 of those. So I'd have x times x times x times x times the square root of x. So I have x to the 4th outside times the square root of x. Okay, so I had 4 groups of 2. So I put x to the 4th on the outside, and then I had 1 left over on the inside. A little trick that's kind of nice to know is that when you have an odd number, you're still going to have a variable under the square root. But if you have an even number, everything gets pulled out of the square root. That's why in this first one here, there's no more square root left. Okay, so odd means there's still 1 left under the square root. Even means that the square root goes away from that variable. All right, so I want you to practice with this one, the square root of x to the 13th. Good luck. All right, hopefully you said x to the 6th times the square root of x would give you your final answer, because there are 6 groups of 2 in the number 13 with 1 left over. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's move on to example 3. So now we're going to be simplifying square roots with numbers and variables, okay? So you can kind of treat it like 2 separate problems, but you're going to combine your answers into one. So if I start with just the square root of 8, I want to think, what are the numbers that multiply into my square root of 8? So looking here, the biggest number that multiplies into 8, that's a perfect square, would be the square root of 4 times the square root of 2. So this would become, the square root of 4 is just a 2, and then I have a square root of 2. Now what happens with the square root of x squared? Oops, that should be a 2. Square root of x squared, that square and that square root cancel each other. So this just becomes an x outside of a square root. So that means if I combine my answers together, it's 2x on the outside and just the square root of 2 on the inside. Okay, let's try another one. So we have the square root of 24. So the biggest number out of these that go into 24 is just 4. So the square root of 24 becomes square root of 4 times the square root of 6. So 2 square root of 6. And then x cubed has 1 group of 2. So I would pull 1 group of 2 out, and I would still have 1 left. So now, looking at kind of like these 2 things together, I'm going to write the 2 things that are outside of the square root together, and then I'm going to write the 2 things under the square root together. So I would have 2x times the square root of 6x. And that would be my final answer. Let's try another one. We have the square root of 56 times x to the 8th. So what is the biggest number that multiplies into 56? The biggest number that would multiply into 56 would be the number 4. Wow, these are all 4. That was unintentional. All right, so we have 4 times the square root of 4 times the square root of 14. So we have square root of 4 times the square root of 14. So this square root of 4 becomes just a 2, and square root of 14 doesn't simplify anymore. So that part's done. Now let's do x to the 8th, the square root of x to the 8th. So I think how many groups of 2 go into 8? That would be 4. And since it's an even number, there are none left over, so that means it stays outside of a square root. So putting those 2 things together, I have a 2 and an x to the 4th outside the square root, and then I have a 14 under the square root. Okay, if you have questions about that, please be sure to ask for some help. I'm happy to help you. Let's move on to question 3. I want you to simplify the square root of 45x to the 7th. Good luck. Okay, for this problem, hopefully you said 45 breaks up into 9 times 5, which is, or the square root of 9 times the square root of 5, which is just 3 times the square root of 5. And then you said x to the 7th, that has 3 groups of 2 in it, and 1 left over. So you have x to the 3rd on the outside, x on the inside. And if you wrote everything together like you should, it is 3x cubed on the outside, or 3x to the 3rd. That's another way to say that, on the outside, times the square root of 5x. If you have questions about that, please be sure to ask for some help. I'm happy to help you. Let's move on to our last example. So now we want to practice multiplying square roots. So we have the square root of 5 times the square root of 48. So my recommendation to you, you can either say 5 times 48, which is 240. So let's practice one way with this. You can multiply them together, and then what you're going to do is figure out, oops, I wrote the wrong squares up top. So we have 4, 9, 16, 25. I want to find what's the biggest number out of these perfect squares that multiply into 240. So I have 64, 81, 100, 121, 144. So if I try 240 divided by, let's see, divided by 64, that doesn't work. 240 divided by 49 doesn't work. 240 divided by 36 doesn't work. 240 divided by 25 doesn't work. 240 divided by 16 does work. So I would say, I know 16 goes in there, and it's 16 times 15. So then the square root of 16 is 4, and then the square root of 15 would break down into a 3 and a 5, which those don't break down any further. So it would just be 4 square root of 15. Okay? Now, let's say maybe you don't like working with that big of a number. So what you can do instead is you can break these up. You can say 12, that's the square root of 4 times the square root of 3. 44 is the square root of 4 times the square root of 11. Let's say this is how you wanted to break it up instead. Do you see how I have a square root of 4 and a square root of 4? Another way of writing that is like this, the square root of 4 squared. So I have the square root of 4 squared times the square root of 3 times the square root of 11. And this square root cancels with that square, leaving me with just a 4. So I have square root of 4, and then the 3 and the 11 don't cancel any further. So these would become 3 times 11 is 33. So I would have 4 square root of 33. So those are two different ways that you can solve these problems. You can either multiply everything together and work with a really big number, or you can break it up into smaller numbers and work from there. But if you have questions about that, please be sure to ask for some help. I'm happy to help you. Let's move on to the same idea, but now with variables. So we have 5x to the 4th times 48x to the 5th, and we need to figure out what simplifies. So something I like to do is actually, I don't like working with the really big numbers. I like to see if I can break up the numbers into something smaller. So I know 5 doesn't break up, but 48, I know if I use those perfect squares, I know 16 goes into 48, and it goes in 3 times. And then I have these variables. I have an x to the 4th times x to the 5th, which we just practiced that when you have the base appears twice and you have 2 powers, you add those together. So this is x to the 9th. Okay, so that 3 doesn't change, and let's say we have that 16 and that 5. Okay, so from here, the square root of 16 is just 4, and then the square root of 5 and square root of 3, those don't break up anymore. So I'm going to say the square root of 15. And then this x to the 9th, 9 has 4 groups of 2 in it with 1 left over. So my final answer would be 4x to the 4th square root of 15x. If you have questions about that, please be sure to ask for some help. I'm going to do one more example before I let you try the last one on your own. Okay, so we have the square root of 12x cubed y squared times 44x to the 5th y. So this 12, I'm going to break down into a 4 and a 3. 44, I'm going to break down into 4 and 11. I have 4 and 4, which we determined earlier is just 4. 3 times 11 is 33. Okay, and then for the variables, I have x to the 3rd times x to the 5th, which is just x to the 8th. And if I were to simplify that, there are 4 groups of 2 with none left over, so it'd be x to the 4th. Then the last one, we have the square root of y squared times y. The second y is like y to the 1st. So if I add those exponents together, I have y to the 3rd. And if I simplify that, there's 1 group of 2 with 1 left over. Okay, so if I write everything, I have a 4 on the outside, I have an x to the 4th on the outside, and I have a y on the outside. Then on the inside I have 33. There's nothing for an x that's left on the inside, but there is a y left on the inside. So that would be my final answer for that problem. All right, here's the last problem for you to try on your own. I want you to simplify the square root of 7m squared n times the square root of 21m cubed n to the 5th. Good luck. All right, for this problem, hopefully you said that 7 and 21, they have a 7 in common. So the square root of 7 times the square root of 7 just becomes a regular 7. Then we have a square root of 3 still left underneath. Then m squared times m cubed is m to the 5th. 5 has 2 groups of 2, so it becomes m squared square root of the 1m that's left over. And then n times n to the 5th is n to the 6th, which is 3 groups of 2, so n cubed gets pulled to the outside. So you're left with 7m squared n cubed times the square root of 3m. If you have questions about this problem or anything else from this video, please don't hesitate to reach out for some help. I am happy to help you. I know this can be a tricky concept, but I promise you that the more you practice it, the easier it'll get, even though it can be frustrating. Okay, so be sure to ask for some help. I hope you have a great day.